Hello students. Today, we're going to explore the concept of Network Address Translation, or NAT. NAT plays a crucial role in connecting private networks to the global internet, allowing devices within these private networks to communicate with the outside world using a single public IP address. Let's embark on this journey together and understand how NAT works, its different types, and its real-world applications. Network Address Translation, NAT, is a technique used to translate private IP addresses into public IP addresses and vice versa. It enables devices within a private network to access the internet using a shared public IP address. This is essential because public IP addresses are limited, and without NAT, we would quickly run out of them. Network Address Translation, NAT, is a crucial technique used in networking to enable communication between private networks and the public internet. There are three main types of NAT. First, static NAT establishes a direct one-to-one mapping between a private IP address and a specific public IP address, often employed for hosting internal services accessible from the internet. Dynamic NAT, the second type, maps multiple private IP addresses to a pool of public IP addresses, conserving public IPs and facilitating dynamic outbound connections. When a device initiates communication, it acquires an available public IP from the pool, which is released after the session ends. Finally, PAT, Port Address Translation, or NAT overload, the most common type used in small networks, maps multiple private IPs to a single public IP using different port numbers. This differentiation of connections by ports allows multiple devices to share one public IP address efficiently. Each type of NAT serves specific use cases, providing enhanced security and efficient management of IP resources in various network environments. Network Address Translation, NAT, is a crucial networking technique, and it encompasses four key terminologies to facilitate communication between devices within and outside a local network. First is inside local, which refers to the private IP address of a device within the local network. Next is inside global, representing the translated public IP address assigned to that same local device. Outside local stands for the public IP address of a device situated outside the local network, while outside global corresponds to the translated public IP address of that external device. The NAT translation process involves two scenarios. The first scenario, called outbound translation, occurs when a device from the local network initiates communication with an external server, such as browsing the web. In this case, the device's private inside local IP gets translated into the public inside global IP to traverse the internet. The second scenario, inbound translation, comes into play when an external device tries to communicate with a server located inside the local network, like accessing a web server hosted internally. During this interaction, the public outside global IP is translated back into the private outside local IP, ensuring seamless communication between devices across the network boundaries. NAT plays a vital role in conserving public IP addresses and securing the internal network, while enabling devices to access resources on the internet efficiently. Static NAT configuration. Static NAT provides a one-to-one mapping of a private IP address to a specific public IP address. In the provided configuration example, we have two interfaces, Gigabit Ethernet 0/0 and Gigabit Ethernet 0/1. Gigabit Ethernet 0/0 is configured with the public IP address 203.0.113.1, and it's designated as the inside interface because it connects to the internal private network. Gigabit Ethernet 0/1 is configured with the private IP address 192.168.1.1 and serves as the outside interface, connecting to the external public network, usually the internet. The command IP NAT inside on Gigabit Ethernet 0/0 indicates that this interface is part of the internal network, while IP NAT outside on Gigabit Ethernet 0/1 designates it as the external interface. The critical command is IP NAT inside source static 192.168.1.10203.0.113.5, which maps the specific private IP address 192.168.1.10 to the public IP address 203.0.113.5. This means that whenever a device with the private IP 192.168.1.10 initiates communication with the outside world, its address will be translated to the static public IP 203.0.113.5. Static NAT is beneficial for hosting services internally, such as web servers, and making them accessible from the internet with a fixed public IP address. Dynamic NAT allows multiple private IP addresses to be mapped to a pool of public IP addresses. This configuration is useful for conserving public IP addresses while allowing dynamic outbound connections from the internal network. In this example, Gigabit Ethernet 0/0 and Gigabit Ethernet 0/1 are configured similarly as in the static NAT example, designating Gigabit Ethernet 0/0 as the inside interface and Gigabit Ethernet 0/1 as the outside interface. The access list entry, access list 1 permit 192.168.1.00.0.255, defines the range of private IP addresses 192.168.1.0 to 192.168.1.255, eligible for translation. The command IP NAT inside source list 1 interface Gigabit Ethernet 0/1 overload sets up the dynamic translation. When devices from the internal network initiate communication, NAT dynamically assigns one of the available public IP addresses from the pool defined on the outside interface, Gigabit Ethernet 0/1. This allows multiple devices to share the same pool of public IP addresses for outbound connections, reducing the need for public IPs while enabling external connectivity. Port address translation, PT, also known as NAT overload, is a variant of dynamic NAT that allows multiple devices within the internal network to share a single public IP address. This is the most common NAT type used in home and small business networks, as it further optimizes the use of public IP addresses. The configuration of Gigabit Ethernet 0/0 and Gigabit Ethernet 0/1 remains the same as in the previous examples. The command IP NAT inside source list 1 interface, Gigabit Ethernet 0/1 overload, sets up the PAT translation. Similar to dynamic NAT, access list 1 permits the range of private IP addresses 192.168.1.0 to 192.168.1.255. However, the key difference is that PAT uses a specific technique to differentiate between devices. Instead of assigning a unique public IP to each device, PAT uses different port numbers to track which device is associated with which connection. This way, multiple devices can simultaneously use the same public IP address as long as they use different port numbers. PAT is incredibly efficient for conserving public IP addresses while still allowing multiple devices to access the internet simultaneously. Troubleshooting NAT involves identifying and resolving common problems that can occur with the network address translation technique. These issues may include incorrect translations, where the mapping between private and public IP addresses is not accurate, overlapping IP address ranges, which can cause conflicts in translation, and misconfigurations in access control lists, ACLs, leading to improper filtering of traffic. To address these problems, if you encounter issues with NAT, it is essential to conduct a thorough examination of your NAT configurations. Verify that the translations are correctly set up and that they match the specific requirements of your network. Double-check for any IP address conflicts or overlapping ranges that might be causing communication errors. Additionally, review your access control lists to ensure they are appropriately configured to allow the necessary traffic to pass through while blocking unauthorized access. Moving on to real-world applications of NAT, it is widely used in different scenarios, including home networks, small businesses, and large organizations. One primary benefit of NAT is its ability to conserve public IP addresses. With the limited availability of IPv4 addresses, NAT allows multiple devices within a private network to share a single public IP address, reducing the strain on the finite pool of public addresses. Another important advantage of NAT is the added layer of security it provides. By translating private IP addresses to a single public IP when communicating with external networks, NAT hides the internal network structure from the outside world, making it more challenging for malicious actors to target specific devices directly. Moreover, NAT simplifies network design by facilitating the coexistence of multiple private networks with non-routable IP addresses. This enables organizations to structure their internal networks more efficiently, without requiring unique public IP addresses for each device. Overall, NAT is a valuable networking technique with practical applications across various settings, offering both address conservation and enhanced security while streamlining network design and management. We hope this video helped you on your journey towards becoming a cybersecurity expert. Remember to subscribe to our channel and turn on notifications so you never miss out on our latest content. And if you found our videos helpful, please give us a thumbs up and share them with your friends and colleagues. Don't forget to check out the links and description for our Anki flashcards and to donate to St. Jude Children's Research Hospital. Your support can make a real difference in the lives of those in need. Thanks again for watching, and we'll see you in the next video.